So how would you cut this semicircle in half so that the area of the top is the same as the area of the bottom? Let's talk about that. So what's up everybody? Thank you for spending a little bit of your time with me today. And if this is your first time here, please subscribe so you will not miss my next video. So blackpenredpen, which is an amazing mathematics YouTuber, just post video on how to cut a triangle in half so that the area of two parts of a triangle are the same. If you haven't watched this video yet, I think you definitely should, and I'll add a card that you can click right here. But in short, the answer is you cut kind of like 1 over root 2 from the tip so that the area are the same. So I made a comment saying, dude, next up, how to cut a cone so that two volumes are the same. And he said it's a good idea. And a few more people came along, and Jake Mo said that the answer would be 1 over cube root of 2 because it's three-dimensional. If you scale down by 1 over cube root of 2, then total it would reduce the volume by half, which is a correct answer in that case, I believe, but it's not something that's generalizable, which is something I'll show to you today. So let's dive to the problem. So I have a semicircle here. For simplicity, let's say that the radius of the circle is 1. The same solution would work for circle of radius r2. Alright, and we ask what is this edge? So that 1 is the same as 2. Alright, so if you don't know how to do this problem, maybe this is a good time to pause the video, get a pen out, get a paper out, and do some scratch work. See if you can come up with an idea on how to solve this problem. Alright, so let's do this one. So what do we do here? In order to have area of 1 the same as area of 2, is the same as saying area of 1 is half of the total area, which we know what the area of the semicircle is, which is a half of the area of the circle, which is a half of pi r squared. In this case, r is 1, so we want to find h so that the area of 1 is half of pi, which is pi over 4. Alright, so that's the name of the game. We look for h that make area of 1 equal to pi over 4. Alright, and from here, there are probably like thousands of solutions to attack this problem. I'm gonna use the way that we use mostly geometry. That will be the way that you use calculus, and here too, we can do integration from 0 to 1, whatever, and set it equal to pi over 4. I'm just gonna use geometry to solve this problem. Alright, so area 1 is something that is unusual to talk about. So let's transform area of 1 to something that we are more familiar with. So I'm interested in the area of this sector of the circle here. And also interested in the area of a triangle trapped by two radius and the cut that we're gonna make here. Why do I interested in those two areas? Well, if we can get this x and y, then 1 will be simply x minus y. Graphically, you can see that this guy subtracted by this guy, you get just the top part. Alright, and these two are a lot easier to deal with than the area 1 itself. Alright, in order to know x, we want to know the angle here. So let's analyze the angle here really quickly. Alright, so what I know is this is h right here, this is 1, and this is right angle triangle. So by using trigonometry, we know that cosine theta equal to adjacent over hypotenuse, the same as h. So theta is nothing but cosine inverse of h. Very nice. So we want the whole angle instead of just half. So if I call this guy alpha, then alpha is twice of theta because this side is going to be the same as this side, and therefore it's going to be twice of cosine inverse of h. Once we have that, how would that help us find the area of the sector of a circle? The way to memorize is the area of the sector is proportional to its corresponding angle. In other words, if alpha is the angle of the sector, since the whole angle of the circle is 2 pi, then the ratio between alpha and 2 pi is the same thing as the ratio between the area of the sector and the area of the whole circle, which is pi r squared. In this case, it's just pi 1 squared, so we have something. So x will be alpha over 2, but alpha is twice of cosine inverse of h. So x will be cosine inverse of h. So let's write that down right here. Alright, so next up, the area of the triangle. Right, so the area of triangle is simply 1/2 times base times height. So if we can figure out how long this base is, we can just do 1/2 times this guy times this guy, right? And this can be done using Pythagorean theorem, right? So we know this is a radius, which we assume is 1. This is h. So this guy, which is half of what we want, if we name it t, then t, h1 form a right angle triangle, which means this triplet need to follow Pythagorean formula, meaning t squared plus h squared equal to 1 squared, which is 1, and we want to know what t is. So we figure out that t equal to square root of 1 minus h. Remember, usually you need plus and minus, but we are talking about length of a line segment here. So it will just be plus of this guy. So the total will be 2t. So the area, so y, which is the area of the triangle, will just be 1/2 times base, which is 2t, times height, which is just h. So 2 and 2 cancel. T times h will just be h times 1 over root h squared. It will just be h times root 1 minus h squared. Alright, so with this, we figure out formula for the area 1, which will just be cosine inverse of h minus h square root 1 minus h squared. So we want to know what h is. Unfortunately, we don't have a good way to solve this problem. Well, if you know how, please leave the comment down below. So in this case, we're just going to use calculator, and h turned out to be 0.40397. So let's circle back to original problem and do some comparison what we have here. Alright, so I drew two pictures side by side. On the left, I have a right angle triangle where these two sides are of length 1. And on the right, I have a semicircle with radius 1. Alright, for this one, we need to go up 0.404 in order to divide two area in half. For this one, as we discussed earlier, you need to go down 1 over root 2 in order to cut it in half, which leaves this 1 minus 1 over root 2, which turned out to be 0.293. Alright, so we actually have different heights here, even though these two pictures are all two-dimensional. This one, you have to go a little bit higher in order to cut the area in half, where this one, you just go up to around 0.3. So that's all I want to talk about today. If you have further generalization of the problem that you want to discuss about, please make sure you leave the comment down below, and I'll make sure I dive into that, do more computation, and show them to you. And for today, thank you for watching. If you haven't subscribed already, please do so. My name is Kwong, and you're watching N Choose K. Peace.